So like I said, this unit, we're going to be doing labs. And so the biggest thing that we do in labs is we take one chemical and then we turn it into a different chemical. Okay, that process is called a chemical reaction. So just write this part right here, the term chemical reaction. You guys don't need to write the full definition. I have it there just in case you need it, but I just need you guys to write this term right here, chemical reaction. And again, a chemical reaction is basically taking some chemicals and changing it into different chemicals. Okay. Yes. No, just write the highlighted part for now. Just that term. Okay. So chemical reactions are where you take some chemicals and then you turn it into different ones. Now, you guys don't need to write this full definition, but I do recommend you guys write this part right here. Reactants make products. So today we're going to be learning about something called a chemical equation, which is kind of like a recipe. It tells you what chemicals you want to start with, and when you mix up those chemicals, what chemicals you're going to be making. Okay, which is basically what we're going to do in lab. I'm going to give you guys some chemicals, and then you're going to turn it into new stuff and see what happens. Okay. Now, you guys don't need to write the definitions down here. They're pretty self-explanatory. The stuff on the left side of the arrow is what you start with. So if this is like a recipe, it's like your starting ingredients. And then the product is what you produce, right? The chemicals that you make. And so today we're going to be learning how to do something called balancing chemical equations. Something that we're going to need to do as we do our labs in the future. Okay, so I'll leave this up here for you guys to copy down, but once you guys are done copying that down, I want you guys to copy down this first problem right here, okay? Now, write it exactly the way I have it. So number one, draw this line, C plus line, H arrow, line, CH4. So copy it exactly the way it is, because when you guys give me your final answers for these types of problems, you got to give it to me in this format. Okay, I'll explain what that looks like in just a second. But this is what a chemical equation looks like. What we're going to do today is learn how to do something called balance it. Not you. Okay, so make sure you guys copy down number one because you're going to have to give it to me in this format. Okay, guys, so let me teach you guys how to balance chemical equations. So you're going to notice that we have an equation right here. This is basically like a recipe. You're going to take some carbon, you're going to take some hydrogen, and when you do a reaction with it, you're going to make this molecule right here, CH4. Okay, it's like a recipe. However, the recipe is incomplete right now because what we need to do is, again, balance it. So what I want you guys to do is write underneath it C and H. Okay, because these are the elements that you have inside of your equation. You got carbon and you got hydrogen. And what we're going to do is we're going to make a table and we're going to count how many carbons and hydrogens we have on the left side and how many we have on the right side. Okay. Okay, so let's look on the left side of the arrow. So I kind of made this line here so that this is the left side. But how many carbons do you guys see on the left side of the arrow? Yeah, just one. Good. And then how many hydrogens? On the left side. There's one right here, so it's going to be one. Okay, so C doesn't have a number, so it's just one carbon and then one hydrogen right here. And it's a little bit trickier now that there's these lines. But on the left side of the arrow, we got one carbon, one hydrogen. Everybody good on that? Okay, let's go to the right side of the arrow. How many carbons do you see on the right side of the arrow? One. Yeah, one. Okay. And how many hydrogens do you see on the right side of the arrow? Four. Good. Okay, so if you guys notice, this equation is not balanced because even though you have the same number of carbons on both sides, you have a different number of hydrogens, right? There's one on the left side and four on the right side. What we want to do is we want to make it so you have the same number on both sides. Does that make sense? Okay, so what we want to do is we want to add to the side that has fewer. We need to add hydrogens to the left side of the arrow. Okay, and so like I said, this is a recipe, and so what we're gonna do is we're not gonna touch this right here. We're gonna keep everything here exactly the same. The only thing we want to do is we want to put numbers in the blanks. Okay, so again, just to reiterate myself, because everyone always tries to change up the recipe and the equation, you don't touch this. You keep it exactly the way it is. You only put numbers in the blanks, okay? So we need to add hydrogens to the left side. So if we have one hydrogen here, how many hydrogens do we need to add? Yeah, we need to add 3 more. So if we add 1, 2, 3 hydrogens on the left side, how many total hydrogens do we have? 4. So all we got to do is put a 4 in front here. And if we put a 4 here, that means we have 4 hydrogens. And now our equation is balanced. You got 1 carbon on both sides, 4 hydrogen on both sides. Yeah. So your final answer, you only put numbers on the lines. You keep everything exactly the same. Okay. All right. So, and there you go. That's a balanced equation. If you don't need to add any of these, you can just leave these blank. Okay? If it's blank, it just means 1. All right. So today I'll let you put in the 1, but later on, as we go through the unit, you're gonna get marked down if you put 1. Okay. Yeah. So I would recommend don't, just out of habit, but yeah. This right here, it's blank, which means you only have 1 of these. So yeah. So just leave it blank if there's 1. All right, so I know this might be a little tricky, so let's do another practice problem together. We got 5 that we got to go over today, but that's the first example, okay? All right, let's move on to number 2. So for number 2, same thing. We're going to count up the elements. So let's look on the left side of the arrow. What's one of the elements that you see on the left side? Yeah, nitrogen N, right? So we see N. What's the other element that you guys see? Yeah, O, oxygen. Okay, so same thing. We're going to make a little table so that we can separate the left side and the right side. And I'm going to give you guys a minute. Let's see if you guys can count how many of each you have on the left side and the right side, okay? So same thing we just did. Count up how many nitrogens and oxygens you have on the left side. So take a minute to do that. You can work with the person next to you, and then we'll go over it in 1 minute. All right, so if we look on the left side of the arrow, how many nitrogens do we have on the left side? Yeah, 1. It's just this guy right here. How many oxygens on the left side? 2. Good. Let's go to the right side of the arrow now. How many nitrogens do you have on the right side? Yeah, just got the 1 right there. And then this is a tricky one. How many oxygens do we have? 4, yeah. So if you guys notice, this is tricky because they're split up. You got 1 right here, and you got 3 right here. So we have a total of 4. So if you put 3, you're close. You just need to add, make sure you add the other one as well, okay? So that was kind of the reason we did this equation. All right, so if we look at the elements, which one of them is not balanced? Yeah, oxygen is not balanced. So if you notice, oxygen, there's 2 on the left and 4 on the right. Which side do you need to add more to? The left side, right? This side is the side that you need to add more to. Okay, so what we're going to do is we're going to add oxygen, but remember, you can't just add oxygen by itself because you got to keep the recipe the same. God bless you. So we're going to add an O2 molecule. Okay, remember, you don't change anything about the recipe. You keep it exactly the way it is, okay? So since you have O2, you have to add O2. Okay, so if I add another O2 to this equation, how many oxygens do we have on the left side now? 4, yeah. So this gets to 4, and now everybody is balanced. So the only thing you need to do is put a 2 in the front right here, and there you go. You're all done. H2 and N2. Oh, then you would have to keep adding until they balance out. So sometimes adding... I'm confused. Sorry. Like this? Oh, I see, I see. And then, yeah, so like this, and then that would make this 2, right? Yeah, so you would have to keep adding to this side until it balances out. So this is called balancing because you just keep adding more and more to both sides until they balance out. Yeah, and so there'll be some problems that we do where you need to do multiple steps. Okay. All right, any questions on this one? Okay, let's try to make it a little bit more difficult. So I'm gonna have you guys try out number 3 and 4. I'll give you guys about 4 minutes. See if you guys can solve out at least one of them. If you can get both of them in the 4 minutes, you're in great shape. But if you just get the one, that's totally fine. I'll give you guys 4 minutes to work with the person next to you, and then we'll go over these in 4 minutes. Alrighty, guys. So let's go over number 3. So what are the two elements you guys have in number 3? Yeah, hydrogen and oxygen. You got H and you got O. Okay. So on the left side, how many hydrogens do we have? 2. And how many oxygens? Good. And on the right side, I'll give this one to you, 2 and 1. Okay, so this time it looks like we don't have enough oxygen on the right side of the arrow, right? So we got to add some oxygen to the right side. Okay, the easy thing would be to just do this, but if we do this, then we're changing the recipe, right? We're adding a molecule that's not already there. So we need to add H2O. We need to add the entire thing. So remember, you add what's already there. Don't add anything new. You can't just add oxygen by itself. You can't just add hydrogen by itself. You have to add what's already there. Yes, so this is why there's multiple steps. Because like Cassie said, now we have 4 hydrogens, right? And how many oxygens do we have? 2. We added 1 to 1, so we get 2. And so we fixed the oxygens, right? But now we messed up the hydrogens, right? So what we have to do now is we need to add some hydrogens to the left side. Okay, fortunately for us, we have to add them like this. We have to add H2. So now we have 2, 4. And so if you guys notice, everything is balanced out. Okay. And I'll give you guys a heads up. Every single equation I give you, it can be balanced, and it can be balanced with small numbers. So if you ever see yourself going to like 10, 11, 12, you're doing something wrong, okay? I'm pretty sure in this class, I'll never give you a number bigger than 8, and 8 is like only 1 or 2 of the problems the entire year, okay? So if your numbers start getting too big, you messed up somewhere in your counting, so it's best to kind of go back and fix it, okay? Yes. No. It'll always stay just like this. Good question. Okay, so like we said, we want to keep everything exactly the same, and we're just going to put in the numbers. So how many H2s do we have in total? 2. You got 1 here, 2 here, so we put a 2 right here. We can leave this blank because we didn't do anything to O2. We added another H2O, so we got a 2 right there. Okay, so there you go. The thing in the box is your final answer. Alrighty, any questions about that one? Guys chilling? Yes. Alrighty, guys, let's do number 4. Maybe some of you guys got to it, but if not, that's all good. We'll go over it together. I think this one's one of the trickier ones. Okay, so we got carbon and we got oxygen. We're gonna make our table. How many carbons do we have on the left side of the arrow? 1. How many oxygens do we have on the left side? 3. Good. Okay, they're split up, but we still gotta count them. Let's go to the right side. I'll give you guys this one. 1 carbon and 2 oxygens. Okay. All right, now we got to add some oxygen to the right side, I guess. So we're going to add oxygen, but remember, we have to add the entire molecule. We got to add what's already there. So we're going to add CO2. Okay, but if we add CO2, it's going to change up all our numbers on the right side, right? So how many carbons are on the right side now? 2. We got 1, 2. Okay. And how many oxygens do we have on the right side? 4. Good. Okay. All righty. Now we got to, yeah, what's up? Yes. Like no carbon here? Then that wouldn't make sense because you have to have carbon and oxygen on both sides. You won't get an example like that. That wouldn't work out. Yeah, because it needs to have both elements present on both sides in order to balance. Sorry, I think I might be misunderstanding your question again. Okay, yeah, I'll once we're done with the lecture, you can bring that problem up and I'll go over that one specifically with you. Is that cool? Okay. Okay, so we fixed up the numbers for the right side. Now we got to go to the left side. So if you guys notice, everything is messed up now, right? The carbons are not balanced and the oxygens are not balanced. So we have an option. We can add either CO or we can add O2. Which one do you guys think we should add? Yeah, we should add CO because if you add CO, now you're going to have 2 carbons on the left side and you're going to have 1, 2, 3, 4 oxygens on the right side. And that's what's going to balance it out. Okay. So there are going to be problems where you have to make a choice of which one to add. And that's kind of the game that you need to play as you're balancing these equations. Okay. Figuring out which one is the correct one to add. All right. So we're going to put a 2 right here because there's 2 COs. And we're going to add a 2 right here because there's 2 CO2s. There you go. That's your balanced equation right there. All righty. Any questions about 3 and 4? I know those were kind of a step up from the first 2. All right, we'll do one more balancing problem. And then I'll let you guys get started on the assignment. Now, don't freak out too much when you see the equation. I promise you the balancing part is really easy. So for this one, the hardest part is just counting all the elements. So do the table that we did, count the elements, and I'm just going to let you guys know when you're balancing it, it's 1 step. Okay, if you're doing more than 1 step, you counted it wrong. So that'll be my hint to you guys. So take about 2 minutes to try balancing this equation. We'll go over it, and then I'll get you started on the assignment. Okay, so like we said, the counting part is the hardest for this problem. So we're going to go through all the elements. Let's see if you guys got all of them. So we got Cu, we got S, we got O, we got K, C, and N. So you have 6 different elements that you're working with. Okay? Okay, next thing we want to do is we want to count up the elements on both sides. I'm just going to go through them one by one and just make sure that you guys got them. We got 1 copper, 1 sulfur, 4 oxygens, and then 1 K, C, and N. Okay, on the left side. Okay, we go to the right side. We got 1 copper, we got 2 carbons, 2 nitrogens, 2 potassiums, 1 sulfur, and 4 oxygens. Okay. Yes. You got it. All right, no worries. Any questions about the count? Just want to make sure we're all on the same page. Okay, so it looks like the only ones that are not balanced are K, C, N, and we need them on the left side. Luckily for us, we got the molecule KCN, so you just add another one and you're all done. Just put a 2 in front of KCN and you're all done. Alrighty, guys. So that's going to be it from me today. Your assignment is posted on Canvas. If you guys have any questions about specific problems or you want to check your answers when you're done, let me know. I'll be more than happy to help you guys out, but I'll give you the rest of the class period to work on that assignment. All right. Good luck, guys.